Alright guys, let's take some time to reflect on everything we've done this year, and let's do the law of reflection. Okay, so right here I have a solid line. This is going to represent a mirror, but I went ahead and extended these lines out as like an axis of reflection. To reflect some points, you're going to use a ruler. You're going to use the law of reflection to make sure that you are reflecting things. So this is about, so object X here, you want to draw a line. This is 1 centimeter. And just make sure you extend it about a centimeter behind. And this would be my X prime. This would be X prime. This would be the image of X. And we come over here. So from 7 to 3, or let's go ahead and just do it like this. All right. 0 to 4, so that's 4 centimeters. Go ahead and draw a line to show me the distance to the mirror. Remember the law of reflection, the distance of the object to the mirror has to be equal to the negative distance behind the mirror. So we're going to go 4 centimeters back. Okay, and this would be Y prime. Let's get this out the way. Okay, so that's Y prime. So this is where my image forms. Okay, now what we're going to do is we're going to establish some sight lines, and you would use your ruler to do this, but it's kind of cumbersome for me to try to do that. So I'm going to go ahead and just cheat and use straight lines. Okay, here we go. So from object to image, even itself, right? I want to even do image to itself. And I'll change the line color for the second part. Let's do green. Object to object image. All right, that was appropriate. Let's do that. There we go. There we go. Object to image. Okay, good. Okay, now what we can do is where the points of incidence are. Points of incidence here. This is where we're going to measure our angle incident. So if this is our ray incident here, this would be our ray reflected. Okay, we're going to measure from here with our protractor. Okay, so we want to make sure to do, so I can make this a little bit bigger here. There we go. Okay, so draw your normal line by using your protractor on the side here. Line up, you see these little lines here in the middle, these 2 lines. Use it like a target, make sure it lines up on your quiz or your notes. Okay, and let's draw a normal line. Make sure you make this normal line nice and long. Here we go. And if you need to, you can extend this line a little bit, because it's not gonna be very nice if I don't have my protractor. My protractor is not able to reach both sides of the ray. It's not going to work too well. So you can extend the lines, a little cheat move, but it's really just a geometry thing. Okay, so let's come over here, use our protractor to measure the angle. Make sure the normal lines up on the 90 degree, and use your protractor. Use your protractor to measure the angle. I can grab the protractor. There we go. So from normal, let's see, 10, 20, 30, 40, 48. So then you're going to write the angle in. It's 48 degrees. And then you're going to measure the other side. Just start at normal again. 48. About this. Get this out the way. All right, here we go. From 90, let's go 10, 20, 30, 40, about 47, 48. Go ahead and mark that arc. 48 degrees. All right, there we go. Let's get this out the way. Okay, so now we've done our, so this is the ray incident, so this would be the angle incident. This is the ray reflected. This is the ray reflected, so this would be the angle of reflection. Okay, so that's how you would do this. Okay. And now, which one can you actually see and not see? Well, if your image did not pass through the mirror, this solid mirror right here, then you would not be able to see it. So X would not be able to see themselves, but they could see Y. They could see Y because the sight line would pass straight through the mirror. The sight line would pass straight through the mirror to the image of Y. Y would be able to see themselves because their sight line passes through the mirror, and Y could also see X. All right, good. So this is how you would do this on the quiz. Okay, now let's look at concave mirrors. The rule for concave mirrors is you would take a ray and emit it from the top of the arrow. When it hits the mirror, you want to reflect it through the focal point, right? That focal point there. That's the first rule. So the first rule is parallel to the principal axis, parallel to this middle line here, the principal axis, and then straight through the focal point. Okay. The rule for line 2, very, very easy, right? It's very easy, is you're going to go opposite way. So instead of parallel and then through the focal point, go through the focal point, and then straight along the principal axis. Okay, and where these two lines intersect is going to be your image. It's going to be your image. Okay, let's see. So your image this time is going to end up being, make sure this arrow lines up right on the dot. So your image is going to be real because it reflected on the same side that your object's on. It's going to be inverted because it's upside down. And it's going to be negative magnification. It's shrunk. Okay, cool. Okay, so let's see. So this is when it's outside the focal point. See that? Okay, now look here. Let's go ahead and do one that's inside the focal point. It's going to be the exact same rules. Okay, so your first line, you're going to go straight into the mirror, parallel to the principal axis, and then make it go through the focal point. You make it go right through the focal point. So watch that again. Okay, now your second line, your second ray is going to do the opposite. It's going to go start from the focal point through the focal point. And when it hits the mirror, what do objects do? And what do light do when it hits a mirror? Well, it reflects, right? And it's going to reflect off the principal axis. You see how this is basically the exact same rule backwards? It's not changing just because it's you're in front of the focal point. The rays are going to act the same way. But now what happens is, remember, your eye and your brain are kind of dumb, and they only think that light travels from straight line sources. So what you're going to do is just try to imagine that if it's reflecting this way, your eye is going to believe that it came from somewhere behind the mirror in a straight line. So all you would do is extend this line this way, like that. Okay? Now, if your first ray reflected downward, your eye is going to believe that it came from a source somewhere over here. So just follow that same angle, and you'll get the intersection that your eye is going to make. Okay? So here's my principal axis. And now you see the intersection is behind the mirror now. Your eye believes that there is some sort of light source that's emanating from behind the mirror, right, in the virtual space. So look what happens when you have a concave mirror with an object in front of the focal point. You end up always with an image that is upright or erect. It's going to be virtual because it's behind the mirror, and it is going to be magnified. And this is really good if you're using a vanity mirror, you're using something to enlarge an image, right? It's always going to be virtual. Okay. Same thing is going to happen down here. Okay, let's go on to convex mirrors. Okay, convex mirrors have the opposite angle, but it's really not that big of a deal. Okay, so let's see. Okay, same thing. Bounce, and it's going to go through the focal point. Now the focal point's over here. Okay. But the rule is the same. It's going to go try to focus through this focal point. And then the second one, it's going to try to go to the focal point, but when it gets to the mirror, it's going to bounce backwards like this. Okay, right? That's what they do. Remember, our first ray is going to bounce from this angle right here. So you're using the focal point to determine the angle that the reflection is going to occur from. Okay, so what you do here is you're just going to sketch this line through, and then bam, you end up with an intersection right behind the mirror right there. So images for a convex mirror are always going to be virtual. They're going to be smaller and they're going to be upright. So let's see if I have another one here. No. All right, well that's good. Just remember that's the rule for that one.